Right. Good afternoon, everyone. Thank you very much for coming. My name is Ofek, and I want to share actually quite a simple idea with you. But first, a story. I had a function. This function was a performance bottleneck that I wanted to address. And the first thing that I tried was to have it memoized, that is, to cache results instead of recalculating them. And when I did, the world broke. That is to say, in random times, once in a while, the function would just spew out wrong results. Here's an additional important bit. The argument was of a class that was both hashable and mutable. It was also a data class, but this is not important for the purposes of this story. And the way LRU cache works, the only way it could work, is by managing a dictionary with the arguments as keys and the result as values. So a suspicion arose, maybe someone was changing my argument after the function call. If someone did that, the LRU cache dictionary becomes garbage because the hash that it stores becomes out of date. But how can I hunt for this someone? Now, the first thing I did was to make this class argument frozen and to make it immutable. For data classes, it is very simple, but that didn't go very well. The myClass objects were composed gradually after initial creation, and so they had to be mutable. Marking the class as frozen complained at a ton of places, and it would have been a non-trivial rewrite to fix that. It also would have created many redundant copies of the data, and also I just don't think it makes any sense. So a different idea was needed. Maybe we could make a myClass instance start its life as mutable and then at the right point make it immutable. What would be such a point? Maybe when further mutations would mess something up. Say when an instance of the class was used as a dictionary key or put in a set. Now, we will go through this journey together, and to get to the bottom line, I did implement this and I was able to debug this problem. But before I share the exact steps of how, let's think about this in a slightly broader context. Here's a very known and fundamental Python fact. For an object to be used as dict-key or put in a set, it needs to be hashable. Now here's a Python pseudo fact. To be hashable, an object must be immutable. That's more of a design decision than a technical necessity. It is not entirely obvious why that is the case. And the way Python sets and dicts are implemented is that they store the hash of an object and a reference to the object. So if someone later mutates, that is to say, modifies the object, the hash/reference pair becomes invalid and bad things happen. That's kind of annoying. It leads to several unfortunate Python idioms. I'm sure that everyone in the room here today had the experience of wanting to collect, say, lists into a set. And you had your lists, you created them and massaged them and mutated them. And before collecting them into a set, you had to copy them into tuples because Python. Maybe we can rethink this. So what do we really care about? We don't want objects to change after being put in a set or dictionary. After being put in a set or a dictionary. To a very good approximation, that means we don't want objects to change after taking their hash. So a thought begins to emerge. Let's try to create together a magic object that turns immutable after being hashed. Let's do this together in several iterations. Suppose I have a class with a single attribute, and the class implements some hash. The first thing I would do to make this dunder hash function make the object immutable is override the instance's set attr with something. Maybe none would have worked, but let's do something a bit cleaner. Let's override it with something that raises an exception. This doesn't work. Can anyone see why? It's a non-trivial piece of Python. What? No. Trying to access A supposedly would try to go through dunder set attr, which does not set A, which raises an exception. I'm sorry, the comment was this is just a function object. What is just a function object? Yes, but this is a function that we're supposed to be able to make use of. Just a second. What I was aiming at is that in Python, special methods are only guaranteed to work correctly if defined on an object's type, not in the object's instance dictionary. This is a quote from the docs. And what it says that in Python, the MRO special cases special methods. When you call a special method on an object, the search for the implementation does not begin at the instance, it begins at the class. So we need to intervene at the class level. Let's do that. Suppose I have a class. This is just the skeleton. And I want to intervene. Second. You can't see my cursor. Never mind. I want to intervene at the class level, at the class implementation of dunder set attr. I cannot set the instances set attr, but I can have the classes set attr inspect state from the instance. This added hash taken, I need to initialize to false and set to true in dunder hash can achieve what I want to. And that still doesn't work. Can anyone see why? The comment was, I have a new boolean now to hash. That's true, but it fails actually before that. It fails because setting hash taken to either false or true goes through set attr. Set attr tries to read hash taken, which does not exist yet, and fails miserably. That's a much easier solution. Instead of using class C's set attr, let's use objects set attr. And that still doesn't work, and I'm actually pointing to a hint as to why. That's the last time I'm going to ask this annoying question. Can anyone see why? Now, I started with an object that, I'm sorry, the comment was that if an object is mutable, it is not hashable to begin with. I implemented dunder hash. I made the object hashable. I'm now trying to intervene to set it as a mutable in runtime. And the last problem here is that object.hash, unlike object.setAttr, is not some reasonable universal default. Object.hash does almost nothing. Object.hash hashes only the object's ID. Some abstraction level, it does make sense. When you're looking at a thing as an object, all it has is an ID. So instead of using object.hash, let's explicitly hash the attributes that we're interested in. And this works. Here's a short demo. First, let's paste the code that we reached together. Now, to test it, let's create 2 instances of this class. Let's verify that they are still mutable. And they are. Now let's do something interesting with these instances. Say, collect them into a set. And I wonder, can we still modify any of them? No, we cannot. The exact exception that I was hoping to get is indeed raised. Don't need to take my word for it. You can scan this and go play in this online IDE for yourselves right now. Now, this is the idea that I wanted to share. If you take nothing else from this talk, I would be entirely satisfied. But since we're already here, let's dig a bit deeper. First, it would be silly to re-implement this for every class that you want to freeze at runtime, freeze during hashing. So let's find some way to package it for reuse. This can go about in several different routes, but I think the most natural one is to package it into a decorator, into a class decorator. And let's dive a bit into the internals of such a packaged decorator. First, didn't I forget something? Aren't there more methods that I need to rep to make sure that an object is immutable? Sorry, come again? I'm not sure what you mean, but we can discuss this afterwards. The first thing that I was missing is del-attr. Deleting an attribute goes through a different Python hook. And there are others. If the object that I'm wrapping is a container, then there are other hooks that I need to intervene in. I need to wrap setItem and del-item. And actually, there are quite a bit of in-place arithmetical and logical operator that modify an object in place. But do I really need to intervene in those? Don't these perform the calculation and then assign the result to an attribute via setAttr? This is a non-obvious question. There's something that I didn't mention explicitly, and that is C extensions. C extensions, in principle, can do everything. They can intervene in the state of every object behind your back, and in general, there's pretty much nothing you can do about it, even if this apparatus was a part of the core language. But NumPy. I don't claim to protect against any modification by any C extension, But NumPy is widespread, and it's beyond widespread, it's ubiquitous. MyPy is used enough to justify explicit consideration. And I did opt to wrap all these in-place arithmetic and logical operators to be able to use my decorator on NumPy classes. These NumPy classes implement, say, iAdd as a C extension that does not go through setAtter. I did mention earlier that I was annoyed by the behavior of lists and the need to copy them into tuples, which might have hinted that I have a better alternative. And in fact, I do. If you inherit list and then decorate the child with lazy freeze, you'd have a list that is frozen when its hash is taken. Except, of course, a list doesn't have a hash function. That's a central feature of a list class. So it's best if you implement them yourselves. I have no idea why are you laughing, but I'm all for it. Please continue. While we are here, let me show you two additional features of the lazy freeze decorator. First, it accepts a parameter debug. When it is set, the decorator collects the stack trace at the point of taking the hash. And when someone tries to modify the state of the decorated class after a hash is taken, it reports not only cannot modify attribute, but also hash was calculated at stack trace, which was useful to me. And another addition is this parameter, frozen attributes with an explicitly specified list. And that is useful in particular in a scenario where you have a custom hash that only considers some of the attributes. These would be the only attributes that you'd want to protect. Sorry, there was a comment? No. Now, I did intend to discuss thread safety, but I think I'll have to skip that. Let me skip just to the bottom line. The addition of hash taken handling does not add new race conditions to existing code. That being said, if you are using hashing in a threaded scenario, you are already deep in the danger zone. If you have a potential scenario where the one thread calculates a hash, which is a very non-atomic operation, while another thread modifies the object, you might want to look into locking your custom hash. But that has nothing to do with the lazy freeze decorator. It does not add new races where previously there weren't any. So this work is available for you. The lazy freeze package is available in PyPI. I urge you to give it a spin, say if it is useful for you. Please, if you do, please tell me if it worked for you, and more importantly, if there were any problems. Of course, I will fix them. And to sum up, 3 points to take away. First is a simple but, well, kind of fundamental idea. Hashing an object could make it immutable. You don't have to accept the dichotomy between hashable objects and mutable objects. You can have middle ground. You can have the cake and eat it too. If you make your custom hash implementation freeze the object, you gain safety without compromising flexibility. We saw together a simple implementation that you can already use as is, these few lines of code that were demonstrated. And there is also a packaged, more mature solution available for your use. That's all I had to say. If there are any questions, I'd love to try and answer. Thank you very much for listening.